Okay, this video is going to be a quick introduction to the midpoint formula and the distance formula, two formulas that you will use extensively when you are solving coordinate geometry questions. I'm going to give you an example of each, give you the formulas, and we will look at an extra example for the midpoint formula. Given 2 points, I went ahead and graphed them for us just to save a little time here. We're going to start by finding AB. Recall that when you have 2 points, capital letters written next to each other, nothing on top, no segment marking, we're referring to the length of the segment. Another way of saying that is the distance between the 2 points. So we are literally finding the length of what we see over here in red on the graph AB. We can count on our coordinate graph horizontally, and we can count vertically. However, we have no way of counting across diagonally, so to speak, on our graph. So that's when we need to apply our distance formula. If you notice on the graph, I literally made a right triangle. And the distance formula actually does come from Pythagorean theorem, where we are figuring out the distance between the x values, figuring out the distance between the y values, which are essentially your horizontal and your vertical components of that right triangle. Check out another video if you're interested in seeing the derivation of that formula. For now, I'm going to give you the formula. Distance formula is the square root of the difference between the x coordinates squared plus the difference between the y coordinates squared. We are going to keep our answer in simplest radical form. Let's walk through this example. You might want to take a minute, label your x coordinates and your y coordinates. Remember, keep your 1's together and your 2's together. It does not really matter which coordinate is 1, which coordinate are your 1's, and which coordinate are your 2's. Plugging in. Square root of, I'm taking my x coordinates, so I'm getting 4 minus a negative 2. Notice I have a double negative there. And what I just did is I took those two and plugged them in. Don't forget to square that quantity. Plus, let's get our y coordinates. Negative 1 minus a negative 4. And again, we're going to square those. I got those, of course, from the end of each coordinate. And that's my basic setup of my problem. Be careful that you don't put an x minus a y. It's x2 minus x1, y2 minus y1. From here, it just becomes a little bit of arithmetic. Minus a negative does turn into plus a positive. So I'm getting a positive 6 squared plus a positive here turns into a 3 squared. Just be careful we didn't get a negative in this case, but a negative quantity squared would still be a positive. So if you want to insert parentheses around these just to make sure you are squaring the negatives, that's a good idea. Common mistake is that we try to cancel the squares, the squared and the radicals, but we're not allowed to do that since we have addition inside the radical. We have to go ahead and square, add, and then simplify our answer at the end. So I'm getting 36 plus 9, giving me a radical 45. Not a perfect square, so I can't get a nice whole number. We can type in our calculator. You're going to get 6 point something, somewhere between 6 and 7. Most likely your teacher is going to want you to keep it in simplest radical form, so I'm going to write my answer that way. Several ways to simplify radicals. I'm not going to go through that right now. I'm going to do the quickest way, which is divide by perfect square factors. 9 times 5 gives me 45. 9 is my perfect square factor. So I can bring out a 3, which is the square root of 9, giving me a 3 radical 5. If you have a calculator handy, you can double check that. Type in radical 45, then type in 3 radical 5, and you should get equivalent decimals, that 6 point whatever you got, for whichever one you do. So 3 radical 5 is the length of my segment AB. Never could have gotten that from the graph. Using my distance formula, I was able to calculate the exact value of that length. Let's go to our second formula. Second formula is the midpoint formula. So I'm actually looking at the same 2 coordinates. They're already on my graph, A and B, and I'm going to find the midpoint. The first thing you need to recognize about midpoint, we are actually finding a point, a coordinate point in the form of x comma y. So you will have 2 parts to your answer. I like to think of the midpoint formula as you're finding the average. Ask yourself how you find the average. If you get 2 tests back and you want to know your average grade, you add them up and divide by 2. This case, we're finding the average of our x coordinates and the average of our y coordinates. So we're really doing it twice. Our formula looks like this. Average of the x's, add them up, divide by 2. Average of the y's, y1 plus y2, divided by 2. Notice I have a comma in the middle. I'm not doing anything mathematically with those two parts. I'm going to list them as a coordinate point. I'm relabeling my x1, y1, x2, y2. Again, the order does not matter, but keep your 1's together and your 2's together. And now I'm going to go ahead and plug in my formula. So I'm taking my x coordinates. I'm looking at -2 and 4. Then I'm going to take my y coordinates, which would be my -4 and my -1. Don't forget to divide by 2. A quick look at your setup. You should have your x's together, and then you should have your y's together. Once your setup is correct, you're simplifying. So I've got -2 plus 4 giving me a +2 over 2, and of course that just simplifies to a 1. That's my x coordinate. My y coordinate, -4 plus -1, is a -5 over 2. Your answer is okay just like that. If you prefer to put -2.5, you can go ahead and give the decimal. I'm going to leave my answer in fraction form, -5/2, and that would be my midpoint. I like to look at my graph just to make sure that my answer makes sense. 1, -5.5, I said is -2.5, so I'm looking at my point being somewhere about there, and that does indeed look like it is on segment AB, and it looks like it could be the midpoint. Probably not accurate enough just to get that from the graph, but it's verifying that my calculations are correct. One last example that we're going to look at is we are going to use the midpoint formula, but we got to look at this question very closely because there's something different about it than the one that we just did. We're given points C and D. We're supposed to find E if D is the midpoint of CE. And that's the trick right there. We're told D is the midpoint of CE. So if we go ahead and use our midpoint formula and plug in, like we did in the last one, x1, y1, x2, y2, we're going to come up with a midpoint of CD. Look at your graph. Midpoint of CD is going to be, I don't know, I'm guessing somewhere around there, almost on the x-axis. Read the question again. It says find E if D is the midpoint of CE. Based on my guess, E is the midpoint of DC, not D the midpoint of CE. So E is actually going to end up somewhere up here, maybe possibly off my graph, just to give ourselves a visual with what we're working with, because if I extend this, and I'm freehanding right now, but if I extend that somewhere up there, D now looks like it could be the midpoint between some larger segment, CE. So how am I going to do this? I can't call D x2 and y2 because D is the midpoint. So what I have is I have some unknown point, E, that I'm trying to find, and that's going to be my x2, comma y2 that I'm going to work with. So I'm going to go back to my formula, rewrite it, and now I'm going to plug in the appropriate numbers. Let's start with what we absolutely know, which is we know we have our x1 and y1. Right here we've got x1 is 5, so I'm plugging that in for x1, and I've got y1 is -3, and I'm going to go ahead and put that over here, -3. Now the rest of that I've got to leave sort of unknown. And I still have that comma in the middle. And now I have two expressions, but I really don't have anything I can solve. I need an equation in order to be able to solve. So what I'm going to do is I'm going to turn this into two equations. I'm going to put sort of a dotted line down the middle of my page and pretend I am now working with two equations. I need to make the equation, but the good news is that you know the answers. This quantity right here is the x value of my midpoint. And you know that the midpoint is point D. So you know the x value of the midpoint, point D, is actually 2. That quantity has to equal 2. Likewise, the quantity negative 3 plus y2 divided by 2 is the y value, y coordinate, of my midpoint, so it has to equal 4. So I'm going to set that equal to 4. And if we get rid of these circles, we really don't need those anymore. We're left with two nice equations here that we can solve. I'm going to work on the left side first, and then I'll repeat on the right side. I'm going to multiply the whole equation by 2, both sides. Get rid of the 2's. I've got 4 on the left side is equal to 5 plus x2, x sub 2. Subtract my 5, and negative 1 is equal to x sub 2. I now know that the x coordinate of my other endpoint, E, is actually going to be negative 1. Same thing on the right-hand side. So I'm going to multiply by 2 on both sides. I'm a little squished up here. Negative 3 plus y2 is equal to 4 times 2, which is 8. And I'm going to add 3, giving me a y value of 11 for, again, my second endpoint. That's what the subscript 2 is telling me. Putting it together, we just calculated that the other endpoint, E, is actually going to be coordinates negative 1, 11. And I'm going to use my sketch over here to just sort of verify that that makes sense. Negative 1, 11, we said it should be somewhere up high. Negative 1, I think my graph goes to 10, so 11 would be up somewhere there. So if I extend this maybe in a straighter line, that's looking pretty good that that's a possible answer. I think my math is okay. Okay, that's one way. That's using your midpoint formula. How can you actually calculate an endpoint given a midpoint and one of the endpoints? I'm going to show you one other way to do the same problem, just an alternative way of thinking about it. So I'm going to go ahead and repeat the coordinates. And this time I'm not going to put in any special orientation on the coordinate graph. I'm just going to go ahead and list it out. So I've got an endpoint, I've got a midpoint, and then my other endpoint's going to go down here. Okay, just so I can see what's going on. So my endpoint was, my first endpoint was C, 5, negative 3. My midpoint was D, that was 2, 4. And then I'm looking for E, that other endpoint over here. And we're going to go with the concept that the midpoint is exactly in the middle between the other 2 points. So it only makes sense that whatever I do to get from one point to the midpoint, one endpoint to the midpoint, I'm going to have to do the same thing to get from the midpoint to the other endpoint in order to keep that point exactly in the middle. So I'm going to mathematically ask myself, what did I do to get from an x value of 5 to an x value of 2 from the endpoint to the midpoint? And hopefully we're seeing that we actually just subtracted 3 there. 5 minus 3 is giving me 2. Well, if I did it there, I'm going to have to do the same thing. I'm going to be subtracting 3. 2 minus 3 is giving me a negative 1. Sound familiar? Let's do the same thing, but let's do it on the other coordinate, the y coordinate. So from negative 3 to 4, how do I mathematically get from negative 3 to 4? Hopefully you're saying something like add 7. Negative 3 plus 7 gives me 4. So I've got to go, whoops, a little further. I've got to go from 4 to something, and I'm going to do the same thing, so I better be adding 7. 4 plus 7 is giving me 11. We just determined that the other endpoint, E, should be the coordinates negative 1, 11. Same thing as what we had right here. Coordinates negative 1, 11. Just a different way of thinking about it. Still showing your work. You're just doing a little bit, not doing all the algebra work, but you're definitely using the concept of the midpoint is exactly in the middle. Okay, that's a basic example for both, plus I tacked on this harder example for you to take a look at. Hopefully that helps with using those two formulas.